My name is Alexander. I work at Microsoft as a principal engineer. Before Microsoft, I was working at Zalando, and I'm maintainer of Patroni. It's a tool for Postgres high availability. The idea for this talk came to me when I was looking a lot into problems with logical replication and logical decoding, what is people trying to use today as a queue. We used a lot like the topic of this presentation at my previous job, and so therefore, like agenda for today, like why do we need in database queue? Like why cannot we use something external, or like cannot always use something external like Kafka, RabbitMQ, and so on? How people usually implement queue inside the database using very famous pattern select for update skip locked. What are problems with this implementation? How could it be improved? And then we go straight into topic of exactly this presentation about PgQ extension. We will look into its internals, how it keeps data, how it keeps its configuration, and so on. Then I will briefly talk about how PgQ could be used on managed services, because like none of cloud providers support this extension, unfortunately. And then we come in to the end. All right, so why people use queue and why people use external queue? Nowadays, people really like to run microservices for like their application in form of microservices, and it means they need to communicate somehow asynchronously between different applications, and usually they rely on something external like Kafka, RabbitMQ, and so on. But as DBA or like person who supports Postgres, I don't really like running something or learning and running in production something external like Kafka. It brings operational complexity, it brings new failure modes, like it brings a lot of additional costs because you have to run a lot of resources to support Kafka. Failure modes actually, like I would say, they're increased because Kafka also can fail, although it's supposed to be resilient. It can fail, for example, not like permanently, but temporary. Like you need to learn how to do retries in your application. And of course, like if you bring some external queue to your system, you get no atomicity. Like the whole setup becomes eventually consistent. So first you like do something in the database, then write it to a queue, and so on. On the other side, like if you implement queue inside the database, you don't need to learn anything new. Like you can rely on rock stable Postgres instead of jumping into new technology, which will be forgotten in a couple of years. I'm not talking about, for example, Kafka, but there are examples which people used and then replaced with other technologies and so on. Like you don't have to spend additional money on running this setup. You can atomically produce events in the same transaction in the database. Let's say you update accounts table, and you can immediately write into a queue some event that describes the change you just did in the same transaction, and they will be committed atomically. It's guaranteed by Postgres. And basically your database remains a single source of truth. You don't have to care about eventually consistent system and so on. And actually, even when you run, like, have to use some external queue, it's still good to have something inside Postgres, because let's consider the situation. You do a transaction in a database and you want to write something to external queue, and external queue somehow is not accessible. You need to implement retries in your application, and if application failed while doing those retries, this event will be lost. So usually people use a different pattern. First they write into external queue, then there is another system which pulls events from external queue, does some changes in the database, and then those changes are published again to a queue, which kind of adds unnecessary circles and in the life in the life cycle of your data. Right, and after all, you end up in having some small queue in the database, and some application or like some microservice will be pulling from this queue in the database and publishing to a Kafka. But basically, like one way or another, you need to have some queue in the database. What people, developers generally implement, something simple and straightforward. Just a single table, I hope it's visible, like with a primary key, with some timestamp field and the message. Very straightforward, like you insert events by doing insert into a queue table. Seems to work fine. And when you need to consume events from the queue, you do something like select for update, ordered by identifier or maybe by timestamp. Since our only index is identifier, we do order by ID and use for update skip locked. So for update skip locked allows us to implement consumption from a queue from multiple application instances in parallel. Of course, we need to do it in a transaction. Otherwise, like select for update will not lock selected rows. While transaction is still in progress, like we process events, and once events are processed in the application, we delete them from the queue. Are there any questions? No, nice. Well, so ordering by time, so we don't have index on the time field, and introducing a new index like brings another problems. Like we can add new index and do ordering by time. Yeah, it's not a problem. So it's just for this very simple example. Right. What are the problems with this approach? Like what are benefits of this approach? Like it's extremely simple. You can do parallel consumption out of the box. You don't have to do anything extra. But disadvantages, like we keep transaction in progress while processing events. Sometimes processing events can take time. Like even if in general you like do processing in milliseconds, sometimes it can jump to seconds, or in worst cases like to dozens of seconds, minutes, and so on. I've seen it on practice, which is bad, like to have long-running transaction. Even if you don't have long-running transactions while processing events, some long-running transaction in the database will affect your queue, which is also bad. Select for update actually updates a row in the database, so it's additional write. And delete also has to mark this row as deleted, so it's again additional write. And effectively it means we need to have like a very aggressive vacuuming of this table. Otherwise, bloat will kill all performance, and there will be no good statistics and so on. And we get something like that circle, that loop, like slow consumers from the queue will result in queue table growth, like or maybe not even slow consumers. Let's say you have a huge spike of inserted events into a queue table, and it grows up to a few millions. And and consumers in generally can consume only limited number of events per second. Then we get some expensive index scans by primary key or like by time. Once we like do select for update and delete, we basically get table bloat, then index scan slowly remaining this becoming slower and slower. And at some point, just a single select for update will take seconds instead of milliseconds. Like I really seen it on practice. And at some point, consumption will become so slow that your table will like grow and grow and grow, and consumers can never keep up. So in fact, so in reality, what developers want and like what DBAs want, avoid keeping transaction in progress while queue is being processed. We also want support retries and so on. And this very simple example, which I showed in the beginning, extended to something like this. We introduce a couple of more columns. One column is like, by the way, it's a real example from one Postgres extension that implements queue. Like a bit simplified, but very close to it. VT, it means visibility timeout. So idea is to use this field and update it on, like after doing select for update, to set when this event should be retried if it wasn't like processed and deleted. And read CT, it's a number of reads that happened to this event. So, and the query becomes something like this. And by the way, like we also have to index, to create index on VT field. So, and the query becomes something like this. It's a CT, like after selecting some number of rows to process, like in the select part we have condition on VT, which should be smaller than the current timestamp, and we do order by ID. Once we selected some number of rows, we do update. We set VT field to something in the future, like some visibility timeout. If current application didn't send feedback about this event, the next application can more or less retry and fetch this event one more time. We also increment number of reads. And of course, like we return all fields from this table. One advantage, we don't have long running transaction in progress because like we wrote some data into the database. Like once processed events, we just delete from the queue. Seems to be a bit better. However, like now we have 3 times of writes into the database. First one itself, insert itself, then we do select for update, which causes write, then we update row again. It's a write into a table, and delete, which also write. However, like since we introduced a new index on VT column, and we also update this column, this way we effectively disabled hot updates optimization. Like hot, it's hit only tuple. And also having 2 indexes with such kind of select may confuse planner, like which index it should choose to run this query. Index on VT column or index on ID column, because we do ordering by ID. Like I can imagine that in the beginning it will start ordering, like start using index by ID, but later over the time when some bloat accumulated, it may flip plan to use index on VT column. And effectively this select may start taking like seconds or even minutes instead of milliseconds. And I also seen it on practice, unfortunately. Right. How can we make it better? Like, what can we do quickly? Like, instead of having a single table for the queue, we can create multiple partitions and, or maybe not even partitions, like multiple tables, and insert like first into a first table, like at some point switch to a next table. And while, so if we processed all events from the first table, we can do truncate. This way we fight with the table bloat. We don't have to do like vacuum full, reindex or something like this. So just truncate, and and it will be already a good improvement. But we can actually do better. Like instead of doing select for update, we can just keep last identifier of event that we processed. Also in a separate table in the database. And when next time we select a bunch of events to process, a bunch of events, we just start from last identifier and order by ID and limit, I don't know, like how many events you would like to process. So basically, we will not do any updates on the table. However, the consequence, it means that like we cannot have more than one consumer per queue, which is disadvantage. Like in the above example, like retries were supported by more or less using visibility timeout field. If we start consuming like by just keeping a pointer to last identifier, like we can implement retries by reinserting events, which also is like I think feasible, good approach. Or like instead of reinventing the wheel, we can just use PgQ extension. This extension is not new on the market, like it exists publicly, only publicly since 2007. And I'm pretty sure it was used like about 1 year, maybe even longer before it was published. This extension was published as a part of SkyTools. SkyTools, it's like set of Postgres extensions and tools which was developed by company Skype. I'm very sorry that Microsoft killed Skype, but anyway. So like if you never heard about SkyTools, it consisted of PgQ extension. Then there was, and actually it still exists and supported PL proxy extensions, which allows you to implement sort of horizontal sharding using Postgres on top of stored procedures. And the last one, but the most famous, it's PgBouncer. I think everyone knows PgBouncer and everyone uses. And it was also a part of SkyTools. I have feeling that Skype company had a very great engineer because they came up with so great products. And those products are still, like after almost 20 years, still in use and doing the job. Right, so like nowadays you can install PgQ from PGDG, like Postgres Global Development Group, and they are packaged as Debian or RPM packages. If you follow those links, you can find instructions how to like install PgQ. However, like most likely you already have like PGDG set up on your machines, and you can just do apt-get install whatever PgQ, like or human install or whatever else. So PgQ implements queue like on top by batching events and it implements it like the interface of PgQ like is like fully SQL. Like there is a whole bunch of PL/PG/SQL function. You can call them by using select and so on. PgQ allows you to register like multiple queues. Like you can have as many producers per queue as you like. Effectively, instead of just inserting into a queue directly, you just need to call a function from like whatever client connection. And single queue can have multiple consumers. Each consumer will see all events. So if you use PgQ alone, it means like you cannot have parallel processing, but there are tricks to make it work. Like how PgQ could be installed. I didn't verify it like with Yum or TDNF by myself. However, like with apt-get, it's PostgreSQL -version -PGQ3. Like it's a name of the package. But next to this package, we also need to install PGQD. Like it's a maintenance daemon. It has to be running because like it does very important job for the extension, and the most important part it's generating ticks. To create extension, we just use normal create extension syntax. So here is the basic usage. PgQ exposes like something like 52, 53 like functions. You can call all of them, of course, but the public API consists of like mentioned functions. Like to create queue, like we call PgQ create queue, you specify queue name, and that's it. Then you need to register a consumer for the queue. To insert event, you use PgQ insert event function. Like the second argument, it's event type, and the third argument, it's like event itself. Of course, and like first argument, it's a queue name. To consume from the queue, like as I said, PgQ uses batched approach. Like first we need to generate a new batch by calling PgQ next batch, and arguments are queue name and name of the consumer. Consumer has to be registered for this queue. And next batch returns batch identifier. It's an integer or big int. It's right now not so important. Once you generated a batch, you use get batch events function, and it will return events associated with this batch. Once you did all the processing, you call finish batch. And of course, like there are a couple of more functions to unregister consumer and to drop the queue. All right, now let's look closer at how PgQ stores data, how extension look like, and so on. If we look at PgQ schema, at all tables that exist inside the schema, there are a few tables, configuration, extension configuration tables like consumer, event template, queue, retry, whatever. And the event tables are tables which were created dynamically when you created a new queue. And this is not a table partitioning, in fact. It's a table inheritance. I will explain a bit later on the next slide. What's important? For the event table, we have, for the my queue, it created 3 event tables with suffixes 0, 1, and 2. The current table is with the suffix 0. You can get this information from queue table. The total number of tables is 3, and like queue name is my queue. Like if we look at table definition of the queue table, you will see that there is just index on transaction ID. Transaction ID, it's a current transaction ID which produced the event, and all other fields like more or less optional. So like who is the owner, number of retries, event type, event data, and some extra fields. Like you don't have to use event type or extra fields. It's not so important because PgQ is just a queue which was developed to support logical replication back in early 2000, like 2005, 6. Right. What's also important, we have fill factor 100%. It means that, like by default, fill factor in Postgres is 90%. This is done in order to optimize future updates. However, in case of PgQ, we are not supposed to have any updates on this table. Therefore, fill factor is 100 to fully utilize space on the page. And what's also important, we have after vacuum disabled for this table and for those tables. This is also sort of optimization to reduce number of, to reduce amount of I/O. And since we are not doing anything except insert and select from these tables, it totally makes sense. So I already mentioned that, like, next to PgQ extension, we need to run PgQ daemon. And one of the important tasks that PgQ daemon does, it generates ticks. Basically, ticks defined by batches. And every time when tick is produced, it inserts into tick table, tick ID and current snapshot, current tick snapshot. Snapshot basically defines which transactions are currently in progress, which and defined visibility of events in the table. I'll explain a bit later on how this tick snapshot is used. Basically, every second snapshot is generated, and all events which were inserted into event table between two snapshots forming a batch, except some transactions that were still in progress when the second snapshot was generated. And in the subscription table, where we keep current status of subscriber, like we just refer last tick and next tick. So like how events look like when we call get batch events. It's just normal select and it returns like events that I inserted on previous slide. But like what happens inside this function? It's quite a complex PGSQL function. It dynamically generates a SQL query. In most cases, it is reading just from one partition, not from all of them. And only in certain cases, when it can detect that transaction ID like is flipping like for between two ticks, it may do union all and select from more partitions. But in most cases, it just uses a single event table. What's important here, like it's relying on index on transaction ID. Basically, it selects all events between two transactions, and those transaction IDs were taken from tick snapshot by using some Postgres functions. In addition to that, it verifies that transaction is visible in the snapshot or like not visible in the next snapshot. Like because original design of PGQ was to support logical replication, and we want to see all events that coming from the same transaction in a single batch. And this is like why it was implemented like this. And last but not least, we order events by event ID. All right, so what happens when we close the batch after processing? Like the only PGQ does, it just updates subscription table by changing last tick to a next value, like sub next tick, and by updating active batch and next tick fields. That's it, like just a single update of a single row. Quite efficient. Of course, PGQ supports retry API. You can like either retry the whole batch by specifying batch ID and like in how many seconds you would like to do a retry. The second option, you can retry a single event, like in some number of seconds, or like you can set a retry time for a single event. You can just specify a timestamp. How it works on practice? Like we get events. In this example, I want to retry all events from this batch. we finish batch, and the next time, like when we get the next batch, we get the same event. Like what's important, event ID is the same, event time remains the same. However, transaction ID is different because like it was reinserted from a table into from retry table into a queue, and we have event retry instead of null 1. It means that like it's a first retry. Any questions? Good. And of course, like data remains also the same. So as I promised, like originally PgQ was designed to have a single consumer like from the queue. Of course, like there could be multiple consumers, but like they will see the same events. You cannot process out of the box from like events from a single queue by multiple consumers in parallel. However, there is yet another extension, which is called PgQ Co-op. It's also implemented by the same people from Skype, and it implements cooperative consumers on top of PgQ. API is very similar to PgQ. You need to register subconsumer, like and arguments are queue name, consumer name, and subconsumer name. Like there is a function to unregister consumer. Instead of using PgQ next batch function, like you need to use PgQ co-op next function, and to finish batch, you also need to use a dedicated function. However, to get events, you need to use the same function as before. Very straightforward, very easy to use. Like on top of that, like I should also mention, PgQ provides a couple of functions to monitor like the extension and like how everything works, like how smoothly it works. One function, it's a PgQ get QInfo. There is not so much interesting information in this function. Like probably the most interesting fields are number of events per second, ticker log, and how many new events, and so on. However, PgQ get consumer info function is a bit more interesting. Like in my case, my consumer wasn't running almost a week, and I made it bold red here. And the good thing is that like there is just a single pending event, like not processed event in the queue. But like sometimes you may get like millions of pending events because your consumer is slow. But again, like at my previous job, we used the PgQ very extensively, and there were situations when like consumers were slow and there were like millions or tens of millions of unprocessed events. However, like eventually consumers are doing their job, and like this number of pending events like steadily is going down to 0 or like to some small number, which is expected. So no surprises. The only problem I've seen on practice when a single transaction generated something like tens of millions of events, and like PgQ was able to produce a batch. It was able to fetch all these events from a batch, send to application, but Java application wasn't able to cope with such number of events and run with out of memory. That was the only problem I witnessed on practice, and like we resolved it by manually closing this batch. That's it. Right. So as promised, PgQ is quite old. Many people think it's not supported or outdated, like whatever you call it. And of course, it's not supported by any of managed services. Like if we look at the big top 3, like none of them provides PgQ. Does it mean that like game is over and we cannot do anything? In fact, no. Like PgQ is mostly PGSQL extension. If we look into Postgres catalog, and find all functions which are not PGSQL. Like in this case, I just looked up for C functions, and we find only 4 such functions. 3 of them trigger functions. They're used to support like logical replication built on top of PgQ. Basically, you set this trigger function on tables you update, or maybe you can even use them like in your specific case. And the last one, which is important function, it's an insert event row. It's also implemented in C, like for performance reasons. And it used to be C implementation for like almost 10 years. Until Marco, like original author of PgQ, re-implemented these 4 functions in PGSQL because and commit says that like it was done specifically to support PgQ on managed services. Like back then it was RDS Heroku, and I'm not sure like probably Google also provides something, but not Microsoft definitely. To use PgQ on managed services, like we need to build it manually. We cannot, of course, we cannot use like packages because we cannot install those packages on managed services. Like we clone PgQ from Git, we do make PL only, and it will generate SQL script like PgQ PL only.sql. And the script we need to execute in the database. And basically, it creates a PgQ extension without creating extension by just creating all objects which are required. That's it. But one last piece in the puzzle, it's a PgQ daemon. Like without PgQ daemon, we cannot do much because like if it's not producing ticks, we cannot do batch processing, and like effectively everything is like not working and does not make any sense. So what can we do like without PgQ daemon? Like we have 2 options. Like we can run PgQ daemon somewhere. Like it could be like some managed Kubernetes. Like it does not consume many resources. It just need to get connection to your database. That's it. Or you can run on some small VM, whatever. Or the second option, we can hack our own solution on top of pgcron. And if we look at pgcron GitHub repo, like there is a huge table of managed services which support or not support pgcron. And in fact, in this table, there is only Heroku which does not support pgcron. Every other managed cloud has pgcron support. What's also nice, for like a couple of years, maybe a bit more, pgcron allows you to generate, to execute jobs every second. Like originally it was possible to run jobs the minimal at 1 minute. Now you can do it every second. And it nicely maps to what PgQ does. PgQ generates ticks every second by calling a function. It also handles retry operations by reinserting events from retry queue to original queues. Like by default, it does it every 30 seconds. And last but not least, it does some maintenance. It rotates and truncates queue tables because like we have like by default 3 partitions, and like not all of them are used at the same time. Like it does some vacuuming of extension tables, but only when after vacuum is switched off, which you should not do. And a few more things related to a couple of more extensions like PgQ node or longdist, which is a name for logical replication implemented on top of PgQ. But like those are not so important, and actually it will be covered. Like what should we do? We just need to set up 3 cron jobs. One cron job will call PgQ ticker function every second. This is what PGQ daemon does, like just executing this function every second. The second job should call our own PGQD.retry procedure, not function, which is important. I will show the source code for these functions on later slides. And the third one will do maintenance by calling PGQD maintenance, and it should be executed every 2 minutes. So what PGQD retry should do? Important, it's a procedure, not a function, because we want to do commits. And this procedure should call PGQ main retry events until this function starts returning 0, basically, when there is no more events to be retried. And we commit after every loop, and like when it starts returning 0, like we exit. This function not by default, it's just always copying not more than 10 events at once from retry table into queues. So sort of optimization in order to avoid having long running transaction. And the PGQD maintenance function is also quite simple. There is nothing. There is literally no logic inside PGQD, which is implemented in the C code. It relies on operations returned by PGQ main operations function. And this function returns a function name, which you have to call, and function argument, which you need to supply to this function. Since we cannot call function when argument, like by using null argument, like we have to do like if else, and like just the first one calls function with argument, the second one calls function without argument, and again we commit every cycle. That's it. Effectively, we like can do what PGQ does by just hacking our own jobs on top of PGCron. Provide example like of PGQD maintenance does not handle vacuuming of PGQD configuration tables, but it's not so important in my opinion, because like you should never turn after vacuum off. Like it should be running and like it should be properly tuned. One side effect of using PGCron to run to re-implement PGQD, like for every job that PGCron executes, it records its status into job run details table by inserting a new row, and it means that this table will grow indefinitely, and you better to set another job that will periodically delete from this table. Basically, that was it. So, all right. In my opinion, like PGQ, it's a great tool that implements Q. It is designed and implemented by real engineers who knows Postgres internals and like how Postgres works. Old doesn't mean that like it's deprecated or unmaintained. Sometimes it is literally stable like a rock, and PGQ supported Postgres 18 out of the box, like no code changes were needed at all. So maintainer just updated README that like Postgres 18 is supported. Most likely PGQ is bug-free. I didn't see like bug reports in the last few years. Like you can just use it. There are not so nice things, like documentation isn't great, or I better say documentation for PGQ is totally absent. Like you need to do your own research, like there are a few PDF slides from old conference which explain how PGQ is working, how like how you can use it and so on. But the good thing is like it's mostly PGSQL, which is a relatively simple language. You can look into source code. There is not so much code inside. And you really learn a lot about Postgres and about like PGQ itself by reading this source. On the internet, there are a few libraries that implementing queues on top of PgQ for different languages like Java, Python, PHP. I'm not sure like if they're up to date, but you can do your own implementation for your own language, and it usually doesn't take more than 1 day. And it works very reliably. Okay, so before like closing and coming back to questions, I would like to do some small announcement. Have you ever heard about POSET conference? Okay, not so many hands. It's an online conference which this year will happen June 16 to June 18. It's organized by Postgres team at Microsoft, but like it's an online conference. It's free for everyone. You can watch it on YouTube. And after conference, all talks are published on YouTube. It's 5 years in a row when this conference happens. And now we still have CFP, like all 4 papers, open for this conference. And it will close morning 2nd of February at 9 a.m. Our time, or like it's like February 2nd, 0 a.m. at Pacific time. Yeah, good. So like other questions? Okay. For data type, you for data type. Yeah, it's everything is text. Like maybe you can wish to use JSON or JSONB, but it does not usually bring much difference. In fact, parsing JSONB data type will be a bit slower than just using plain JSON data type. And plain JSON type on disk is stored exactly the same way as a text. So like text is universal in this case, and like you can encode everything. So like first we produce a batch, we call next batch, like it generates a batch ID. If like after calling get next batch, get batch events, or even without calling batch events, get batch events, consumer is gone. Once it's restarted, consumer again calls next batch, and PGQ just returns the same identifier, like the same batch ID. Yeah. So like it literally checks, okay, so we still have batch in progress, like it's not finished yet. So then we will just return existing batch ID. And only when batch is not in progress, it will produce a next batch and generate a new ID. Yes, batches definitely can have multiple events. Yes, correct. Yeah, like so actually there are more functions in PGQ than I showed here. Like there are also functions that allow you to mark some specific events as processed. Like you may do not just finish batch, but like mark, so call a different function which will mark event in a batch as processed. And next time, like it will not be returned. Yeah, but so ideally, like none of Q implementations guarantee exactly once delivery. Like the best they guarantee at least once delivery, and it means that your application is supposed to somehow cope with the fact that some events may arrive multiple times. You either do some idempotent processing, or like you keep some internal state somewhere to like filter out such events. Yeah, good. All right, thank you. You can catch me outside of room and ask more questions if you like. Good.